Hello, it's me again, Joseph Kwabnater, and I'm here to help you solve a physics problem. So now the problem before us is we want to check what would be the difference in the weight of a fish placed in an elevator as the elevator moves up or down. This is a very interesting experiment, so follow me as I help you understand the physics behind this. So now we have a fish attached to a spring balance in an elevator. Now the weight of the fish is acting downwards. So the weight of the fish is the mass times the acceleration due to gravity, which is indicated here. And we have tension in the string. Now the string is what is holding the fish to the spring balance. So T. So the tension of the string is also acting upwards. Good. So now we are going to check as the elevator moves up or down, how it will affect the weight of the fish. Now, if the elevator moves up, we'll have a positive acceleration, and if it moves down, we'll have a what? Negative acceleration. Now, the weight of the fish is proportional towards the tension of the string, and I'm going to solve this theoretically for us to see, and after that I'm going to prove it with actual values so that we'll know what's actually going on here. Good. So we are going to use Newton's second law to solve this problem. Now we are going to use sigma F, which is the sum of the forces. Now as you can see, the motion is in the y-axis, so sigma Fy is equal to ma, where m is the mass of the fish and a is the acceleration. Good. So we know that now we are going to check the forces acting, the sum of the forces acting in the y direction. So now we have the tension of the string T, which is acting upwards, which is in the positive direction. And we have the weight of the fish, mg, which is acting downwards, so it will be in the negative direction. So T minus mg is equal to ma. Hope you are following. It gets interesting as we move on. Now, we want to make t the subject of this equation. So we are going to do a little substitution here, a little change of subject. So t is equal to ma minus mg. Now, in this experiment, we are investigating the change in the weight of the fish. So we want the weight to stand alone whilst we isolate the rest. So we are going to isolate the weight. So T is equal to, we'll bring mg out, all over a over g. Sorry, this plus is plus, sorry. Since I moved the m to the other side of the equal to sign, it becomes plus. But in the form I wrote minus, sorry, my bad. So it becomes plus 1. Now, this is what we've gotten. So now we've gotten that, so as I said earlier, the weight of the fish is proportional to its tension. So we can see it here, you can see the proportion. Now we've gotten the weight here, we've also gotten an expression here, which will account for the difference in the weight of the fish. Now, this for the first part, if the elevator moves upwards. Upwards. Now, since we have this equation, we don't need to solve again for the second equation if the elevator moves downwards, because here we can deduce that if the elevator moves upwards, acceleration is positive, and if the elevator moves downwards, acceleration is what? Negative. So we'll have the formula T is equal to mg into bracket minus a over g plus 1. Hope you are following. So here, the motion is what? Downwards. Now, I've proved it to you theoretically and what? Yeah, mathematically. Yeah, it has been proved. Now we are going to test with actual values to see how it works here. So I'm going to clean the side of the board. We are going to test with actual values. Now cancel. Good. We have a clear board now. Now we are going to check this with real values to see how it affects, just to prove this. Okay. So now our first question is, when the acceleration is -2 meters per second squared. So we are going to put it into our formula we had in the first part. So our formula was T is equal to mj into bracket a over g plus 1. This was what we got here. Now we know mg, which is the weight of the fish, to be 40 Newton. So we've got mg is equal to 40 Newton. And a to be -2 meters per second. Now we are going to put it into the equation. We'll get T is equal to 40 Newton into bracket -2 meters per second square over G is the acceleration due to gravity. So it will be 9.8 meters per second square plus 1. Now punching this into our calculator, we are going to get T to be equal to 31.836, which we can take as 31.84. Good. So as I said earlier, the tension of the string is proportional to the weight. So this is now the reading on the spring balance. The tension of the string is proportional to the reading of the spring balance, and it's also proportional to the weight of the fish. Now we've gotten 31.84. So as the elevator moves down, we'll have a negative acceleration. So the mass of the fish, the weight of the fish, will be reduced to 31.84 Newton. Never forget your units, they are very important. Good. Now we are going to check it the other way. When the elevator moves up with an acceleration of 2 meters per second. So we are going to have T is equal to 40 Newton into bracket 2 meters per second square over 9.8 meters per second square plus 1. Punching this into a calculator, we are gonna get T is equal to a stunning 48.16 Newton. So we can see from here, as the elevator goes up, the weight of the fish increases by 8.16 Newton. So from here, I've proven to you that as the elevator goes up, your weight increases, and as it comes down, your weight decreases. Thank you.